In March 2025, a spacecraft on its way to Jupiter activated a radar system designed for one purpose: to see through ice, to search for what may be hidden beneath it. The spacecraft wasn't at Europa yet. It was passing Mars, using the planet's gravity to adjust its trajectory during a journey that won't end until 2030, but engineers needed to test the instrument before it arrived. The radar is called Reason. It is mounted on Europa Clipper, the largest interplanetary spacecraft NASA has ever launched. And when scientists analyzed the data from that first test in space, they realized something important. The instrument worked exactly as intended, which means that in just a few years, humanity may finally be able to peer beneath the frozen surface of Europa into an ocean hidden from the universe for billions of years. And whatever exists down there may change everything we thought we knew about where life can exist. The question that keeps scientists awake. This is not a mission about geology. Europa is a moon of Jupiter, roughly the size of Earth's moon, covered in a shell of ice, orbiting one of the most violent radiation environments in the solar system. From a distance, it looks frozen, still, dead. But beneath that ice, scientists believe, is an ocean, a liquid saltwater ocean that has been hidden from the universe for billions of years. And if that ocean exists the way the evidence suggests, it may contain more water than all of Earth's oceans combined. If life exists anywhere else in our solar system, Europa is one of the most likely places to find it. A moon that shouldn't look like this. Europa orbits Jupiter at a distance of roughly 670,000 kilometers, so deep inside Jupiter's radiation belts that any spacecraft passing through them accumulates radiation damage fast. Europa Clipper is designed to survive 49 flybys. It will not orbit Europa directly. It cannot. The radiation would destroy it too quickly. Europa's surface tells a story that took decades to begin reading. It is one of the smoothest bodies in the solar system, almost no large craters, where impact craters exist on other moons. Accumulated over billions of years of collisions, Europa's surface seems to have erased them. Something beneath the surface has been resetting it. What covers the moon instead of craters is a network of lines, thousands of them, long shallow ridges and fractures crisscrossing the entire surface in intersecting patterns, some stretching thousands of kilometers. They look, in certain photographs, like the cracked surface of a frozen lake, the kind of pattern you see when ice above liquid water shifts, fractures, refreezes, and shifts again. Beneath that frozen crust may be an ocean containing more water than all of Earth combined, and that ocean has been hidden for billions of years. The first clues that something was there. The evidence for Europa's ocean didn't come from one discovery, it accumulated. The Voyager spacecraft flew past Europa in 1979 and returned the first close images of that fractured surface. Scientists noticed immediately that the terrain didn't match what they expected from a geologically dead body. The lines were too fresh, the surface was too smooth. Something had to be resurfacing it. Then came the Galileo spacecraft, which orbited Jupiter from 1995 to 2003 and made multiple close passes of Europa. It detected something that no model of a frozen, dead moon could easily explain: a magnetic field disturbance around Europa that changed in sync with Jupiter's own rotating magnetic field. The most straightforward explanation was a layer of electrically conductive material beneath the surface, the kind of conductivity you get from salt water, the kind of conductivity an ocean would produce. And then Galileo detected something else: water vapor plumes, enormous columns of material erupting from Europa's surface and venting into space. The Hubble Space Telescope later confirmed similar events on multiple occasions. Europa wasn't just hiding an ocean, it was leaking it, and that discovery changed the entire mission. And this is where things started becoming difficult to explain. What may be waiting below? An ocean alone isn't enough. Water is common in the solar system. Ice exists on moons, asteroids, comets, and planets across the entire solar system. What makes Europa different is what may be happening at the bottom of that ocean. Jupiter's gravity doesn't just hold Europa in orbit, it needs it. The gravitational pull from Jupiter and the competing tugs from Jupiter's other large moons, Io, Ganymede, Callisto, create tidal forces inside Europa that flex and compress its interior with every orbit. That flexing generates heat, and that heat may be doing something at the ocean floor that changes the entire picture. On Earth, at the bottom of the deepest ocean trenches, there are hydrothermal vents. cracks in the seafloor where superheated water rich in minerals and chemical energy erupts from the rock below. When scientists first discovered these vents in 1977, they expected to find nothing living there. No sunlight reaches the deep ocean floor. No photosynthesis is possible. The conditions seemed too extreme. What they found instead was an entire ecosystem: tube worms, crustaceans, bacteria, complex communities of life, thriving entirely on chemical energy rather than sunlight. Life that had never heard of the sun. And it changed how scientists think life begins. Conditions like these exist near life on Earth. If Europa has hydrothermal vents, and the tidal heating makes it plausible, the chemistry required for life may exist at the bottom of an ocean that no sunlight has ever touched. But the most unsettling discovery wasn't the ocean itself. It was evidence that something beneath the ice may still be active. A world still in motion. In 2019, a team of scientists led by Brittany Schmidt at Georgia Tech published a study examining Europa's surface features in detail. What they found was that certain regions of Europa's ice shell showed signs of a process called chaos terrain formation, areas where the surface appeared to have melted, shifted, and refrozen from below. The implication was striking. Pockets of liquid water may exist not just at the base of the ice shell, miles down at the ocean interface, but also within the ice itself, closer to the surface than anyone had previously thought. Europa may still be changing. Something under the ice is moving, and scientists still don't fully understand what's causing it. In 2021, a separate analysis of Galileo's magnetic data suggested the subsurface ocean may be in direct contact with the rocky seafloor, not separated from it by a thick layer of ice at the bottom. That contact matters because it means the ocean water could be interacting with rock, dissolving minerals, acquiring the chemical complexity that life on Earth depends on. And in 2023, the James Webb Space Telescope detected carbon dioxide on Europa's surface, specifically on the younger, geologically active regions, consistent with carbon-bearing material, originating from the subsurface ocean and being transported to the surface. Carbon in the ocean, on the surface, cycling between them. The pieces were assembling into a picture that nobody had fully anticipated. Life in a place with no sun. For most of human history, life and sunlight were assumed to be inseparable. Every ecosystem anyone had ever studied ultimately traced its energy back to the sun. Plants and algae captured solar energy through photosynthesis. Everything else ate them, or ate something that ate them. The sun was the foundation of the entire chain. Europa suggests life may survive in total darkness. If microbial life exists in Europa's ocean, and nobody is claiming it does, only that the conditions may be suitable, it would be life that has never seen light, never needed it, never evolved to use it. Life sustained entirely by the chemical energy of a hidden ocean warmed by the gravity of a distant gas giant. That would be the most significant discovery in the history of science, not because it would tell us there is life in Europa specifically, but because it would tell us that life doesn't require the conditions we assumed it required, that the rules are broader than we thought. That in a galaxy of 400 billion stars, many of them orbited by icy moons with subsurface oceans, life may be far more widespread than any previous model allowed. Europa forced scientists to rethink how common life in the universe might actually be. What the radar will tell us. Europa Clipper arrives at Jupiter in April 2030. Its first Europa flyby follows in March 2031. Reason: the radar instrument tested at Mars in 2025 will operate as close as 25 kilometers from Europa's surface. It will transmit radio waves through the ice and measure what bounces back. Ice thickness. Internal structure. Pockets of liquid water within the shell. The interface between the ice and the ocean below. For the first time, we will have a direct measurement of what lies beneath the surface, not indirect evidence from strange magnetic signals, not a glimpse from a distant telescope, but a radar image of the hidden structure of another world's ocean. The mission is not designed to detect life directly. It is designed to determine whether the conditions for life exist, but the data it returns will be the most detailed portrait ever assembled of an ocean that has never been seen. The ice has never been broken. Right now, Europa's ocean is sealed. The ice shell above it, estimated to be between 15 and 25 kilometers thick, has kept that ocean isolated from space for billions of years. Whatever exists down there, if anything does, has been evolving or persisting in complete isolation for longer than complex life has existed on Earth. No probe has ever touched Europa's surface. No instrument has ever penetrated the ice. The ocean below remains entirely beyond reach of any technology we currently possess. A hidden world sealed beneath kilometers of ancient ice. And right now, no one knows what's truly beneath the ice. Europa Clipper will not answer that question completely. It will tell us whether the ocean is there, whether it contacts the seafloor, whether the chemistry is right, whether the ice is thin enough in places to make a future landing mission viable. The answer to the deeper question, the one that matters most, will require a mission that doesn't exist yet, because whatever may exist beneath the ice has never been seen. Reaching it will require something we haven't built yet, a lander, a drill, something capable of reaching the water. What the ocean has been doing. Somewhere beneath Europa's frozen surface, an ocean has remained hidden for billions of years. Whatever chemical processes have been unfolding in that water, whatever reactions have been occurring between ocean and rock, whatever the tidal heating has been doing to the chemistry, have been occurring in complete silence, completely unobserved, for longer than any human concept of time easily accommodates. Europa Clipper is the first serious attempt to look. For the first time in human history, we are preparing to peer beneath the ice of another world, and whatever exists down there may already be alive. Do you think there's life beneath Europa's ice? Let me know in the comments. There are still oceans, planets, and hidden worlds in our universe that we barely understand, and the deeper we look, the stranger everything becomes. Subscribe if you want to keep exploring.